Hi and welcome. This video is part of a complete Terraform course I have available. The link with the big discount is on the description. Make sure to check that out and let's get started. Hello and welcome back. Let's quickly review what we have done so far before we continue with deploying an EC2 instance inside of the created subnet. So we started by deploying a VPC and a subnet. They are inside of our networking file. Here is our VPC and here is our subnet. We have also deployed an internet gateway and we have associated it with the VPC. So we have done this here on this resource by passing the VPC ID. We have also set up a route table with a route to the internet gateway and we have associated it with the subnet, right? So this is here, our route table, and then we have the route table association. Last but not least, we saw a nice way that we can provide some common tags to our resources, as well as to allow providing or merging these common tags with some custom tags that we can define at the resource level. Our plan for this video is to deploy an EC2 instance inside of the created subnet. Actually, let me change this a little bit here because after we associate the public IP and the security group that allows public ingress, I would like to change the EC2 instance to use a publicly available Nginx AMI so that we can check whether this instance is up and running. But I do think that it makes sense if we try to change the instance, the AMI, the Amazon machine image here, to a publicly available Nginx image. And this is provided by Bitnami. It's free of cost. You would pay only for the EC2 instances. But since we are using a free EC2 instance within the free tier, it's going to be without costs for us. I think it just makes sense that we wrap this up with something that's working, and then we can also experience a little bit how Terraform manages changing the AMI ID here, changing the underlying Amazon machine image of our EC2 instance. And last but not least here, let's add another command or another step, and that's just going to be destroy everything. Right, so we want to make sure that we have no resources that could potentially lead to any bills. So we're going to destroy everything with Terraform. Great, so let's focus on deploying an EC2 instance inside of the created subnet. Let's create a new file here. I'm going to call this compute.tf, and we're going to start by creating a resource, which is going to be an AWS _instance, and this represents behind the scenes an EC2 instance, and I'm going to call this web. Okay, the first argument that I need to pass here is an AMI ID, and here, how do we find this out, right? So this is not just a common name that we can find on the AWS console, and sometimes it's not very easy to figure this out. A little bit down the road, we will see one way that we can fetch this AMI instance or this AMI ID from within Terraform by using a data source. But for this point in time, I want to show you a page where you can look for AMI IDs for basic or for the base Ubuntu images. There is this neat page here, Cloud Images Ubuntu Locator EC2, that you can visit. And I'm going to add this to the resources of this lecture. And here you will have a list of all the images that are available based on the zone as well. In AWS, as you can see here, if we take two different zones and you compare the AMI ID column, you will see that they have different AMI IDs. I am using the EU West 1 zone, and I would like to maybe take a somewhat more recent version. Let's take like the Gemmy Jellyfish, and here we could have a look. Let's see if we find EU West 3, and maybe here let's look for EU-West-1, and then we can find it here, right? So EU West 1, you could also order this by the zone here. So let's see if there is a better way of doing that. Yeah, that looks a little bit better, even though the zone here is not really trustworthy in terms of ordering. Let's just refresh the page and let's see if maybe it's trying to order by both of them. So let's see here. No, that's not really the best way of ordering. So let's look for our version. We're going to have it like this, and then you can look for your zone. I'm going to look for EU West 1. And this is the AMI that I am interested in. So I'm going to just look here on the AMI ID, and this is the AMI ID that I will take. Back in the code, you can just paste your AMI ID here, And another thing we would like to do is we would like to associate a public IP address, right? So this is going to be set to true. The next argument we need to pass here is the instance type. And the instance type, we're going to stay with t2.micro. I believe this is the one that is most widely available in the free tier. In some regions, t3.micro is also available. Let's come back to the t2 one. And let's quickly jump into the console and see how we can figure out this information. So if you come to the free cloud computing, computing services page, and you will see here there is a compute free tier, 750 hours. And then you just look here, 750 on T2 micro or T3 micro instance, dependent on region, right? So this dependent on region here is pretty tricky, because if you are not in a region that supports the T3 micro instance, then you might incur some billing in case you launch an instance with t3.micro. So let's have a look here in our console. We're gonna go to the EC2 page, and if you have visited it, it will appear here. Otherwise, you can just type it here on the top and click on EC2. And now we're gonna come to instances, or we can directly click on launch instance here. And then you will see here at the bottom, let's scroll down a little bit, you will see here the instance type. Right, so if you were to then click here on compare instance types, you can, let's see if it appears here already. Yes, it does. You can set free tier eligible equals to true. Right, so once we do that here, for me, only the t2.micro instance is free tier eligible. Let's see if we can change this to some other region, maybe EU East 1. Let's see if there are some other instances that are free tier eligible. You can also expand this here and look for T3, for example, but no, this is also not available here. So as you can see, it depends on the region. I'm not going to keep looking for all of them until I find one. I'm just going to trust what AWS is telling us here, that eventually you can get also a T3.micro, but for us that doesn't really matter. Okay, so here basically you can find whether the T3.micro is available in the free tier or not. Once again, we don't want to launch an EC2 instance with this console. That's the whole point of using Terraform. We don't want to use the console, right? So let's go back to our code here and continue the definition of our resource. We also can specify a subnet ID, and the subnet ID, I'm just going to use the AWS subnet public.id. And also here, we can specify some additional information regarding security groups. We're going to do that in the next lecture. But for now, for us to be able to launch something, we also need to declare a root block device. The root block device that we will create, it will be deleted on termination. That means whenever we terminate this instance here, whenever it is either terminated or destroyed by Terraform, then it will also remove the root block device. This is best practice for us to avoid having kind of devices which are just existing without any purpose, and that could end up leading to billing. We're going to also define a volume size that's going to be 10, and that's in gigabytes. And we're also going to specify a volume type that can either be GP2 or GP3. I'm in the page here of our free cloud computing services with the EBS selected here. And this doesn't say anything regarding the volume type. It says any combination of general purpose. This is the GP it stands for, right? So GP2 is general purpose version or generation 2. And GP3 is general purpose generation 3. And we could also have some magnetic disks. So I think it's safe to use the GP3 volume here since it provides a little bit more performance. And that is perhaps what you would like to use. However, for us, once again, since this EC2 instance doesn't do anything, it doesn't really matter. I'm just going to leave this as GP3. Let's save this. Let's once again here format our code. And let's see if our plan is going to work. Great. So as you can see here, we have a plan that seems to be working. Let's see if the Terraform apply command is going to work as expected. I will also pass an auto approve here since we know what we want to apply and we are fine with it. Let's see how long it takes. And as you can see here, it gives us an error. And this error is very interesting because I didn't really pay attention to that when we were selecting our image. And as you can see here, the ID that I selected is from an image with an ARM64 architecture. So if you press once again, you see here on the top, we have 3 out of 4. So there is also another version, which is an AMD64 architecture. And this is the ID that we probably want. So let's copy this, go back to the IDE, change our AMI ID here on the top. You see that it's different. Let's save this and then once again try to apply our changes. And hopefully this is gonna work now without giving us any error. You can see that the creation of EC2 instances is it takes a bit more time than the creation of VPCs, internet gateways, and all the other resources we have created so far. There are a few more operations that are run by AWS and whenever we are creating a new instance. So it does take roughly 30 seconds. But at the end, you should also see this message here that one resource was successfully added. Let's then in the browser here come back to our EC2 console and let's give a refresh. And the moment we do that, we will see our EC2 instance here, which has been successfully launched by our Terraform code. It does have a public IPv4 address here, so we could theoretically reach it out via the browser, but nothing's gonna happen here because of course we have nothing running. If we scroll down a little bit more and we click on security, we will see that there is a security group attached by default to this instance here. So before we dive a little bit deeper into security groups, I believe it's a good time for us to take a short break. Before we do that, let's quickly go back to our code here. And if you would like to remove this instance here, as it is right now for us, the only way or the easy way of doing that is by just commenting out this code. Okay, so we're gonna comment out this code. That means that Terraform is simply not going to find, it's not going to be able to find an AWS instance web in the configuration files. Therefore, it will think that we have removed it and it will want to destroy this resource. Let's have a look at our Terraform plan command, and then you will see here that it wants to destroy one resource. That is fine for us. This is exactly what we want to do. So let's run a Terraform apply. And then here, once the plan is here, we can check, okay, that's one to destroy. I will confirm this with a yes. And I just want to highlight here for you that we have run a Terraform apply. We did not run a Terraform destroy. The Terraform destroy would basically destroy everything. We want to remove only one resource that we have commented out from our code. This is a temporary fix because I don't want you to have this resource deployed because I don't know when you're going to watch the next video. So if you're going to watch it in a month, it doesn't make sense for you to consume 750 hours by having an idle instance deployed. If you're going to watch it in 5 minutes, then you don't need to do this step here where we are removing it because we're going to recreate it right at the beginning of the next lecture. So this is more like a security measure here for us, just not to have idle resources running on the cloud. If we scroll down a little bit here, you will see that one resource was destroyed, which is exactly what we wanted. Perfect. So now it's a great time for us to take a short break and come back in the next lecture.